All right, good morning, my friends. The last topic before we take our test this week is just finishing up some stuff about triangles, angles, and sides. We're going to look at some relationships between angles and sides, and then sides and sides. So what better place to start than a triangle? And so the first thing we want to look at is I have a triangle ABC. It's set up to where I can move everything, and everything will just change with it accordingly. And what we want to look at is just a couple things. This one is kind of the basis for that isosceles triangle theorem. So it's just a little bit off because of rounding, but if this is 8, this is 8, it's an isosceles triangle, so the base angles are the same. I wonder if I'll worry about that later. Just understand that's because of rounding. So if I continue to move it around, we can look at different aspects. But what we really want to look at is if I am right here, 34 degrees, notice how 34 is the smallest angle. 35 is over here, 109. But if I look at the opposite side, 7.6, the opposite side of the smaller angle is the smallest side. The opposite side of the largest angle is the largest side. It's something that seems pretty intuitive, but it's a big idea, especially later on in trigonometry. The side opposite of the largest angle right here is the largest side. The side opposite of the smallest angle is the smallest side, and the side opposite of the medium angle is the medium side. So that's our first main point. The first main thing we want to look at is that if I have a triangle and it's A, B, C, if angle A is less than angle B, and that's less than angle C, then side BC will be less than side AC, and that'll be less than side AB. So overall, it's the idea that the smallest angle is across from the smallest side. Smallest angle is opposite from the smallest side. And that's that. That's all we need to think about from there. So sometimes you'll look at variables on other sides, and you'll have to determine what the variable is to understand what the angles are. But overall, the smallest angle is across from the small side, largest angle across from the other, from the largest side. So now let's go ahead and let's go talk about the slightly more interesting one. We're going to talk just side lengths here. So I have this set up already. We talked about how when we are doing the making a triangle, we can have this length here. So 10 is my fixed length. 10 is my base length. So I'm looking at 10. But then I have this set up to where I can make 4 bigger. I can make that A side bigger. So 6 corresponds to the 6. And I can make this side bigger over here too. And no, that's how we make our triangles, right? We find the intersections. That okay, this point is 6 away from B, and it's 6 away from A. From 8, it's 7, or 8. And then I know that that point right there is 8 away from B, but 6 away. So we're looking for that intersection point. So I want to look at a couple things here. So here, I want to look at what makes a triangle, what can make a triangle. So I want to look at a couple things that do make a triangle first. And so if I have the lengths 6, 8, and 10, that will make a triangle. So let's go over here and just write that down. So I have 6, 8, and 10, and that makes a triangle. All right, let's go look at another one. Let's see here. What if I did 4, 9, and 10? So let's go check out 4, 9, and 10. And that makes a triangle. Now let's look at some that don't make a triangle. So if I put this all the way down here, there's no intersection point. So 4, 5, and 10 don't make a triangle. So 4, 5, 10 do not make a triangle. And then we can really look at any other side in here too, right? So we could say 2 and 3 do not make a triangle either with 10. So 2, 3, 10 do not make one. But then there's one more that I want to look at. So what we start looking at is saying, okay, well, what do we have here? Well, I have larger numbers over here, but specifically, what are we looking at? We're looking at the fact that here I have 4 and 10, but what's special about the 9 and the 5? But if we look at what's going on in here, if I go to my 4 and my 5, I just don't have enough distance from B to get to this line right here. So the entire distance is A. So if we think about our segment addition postulate, I know that I want to at least be able to get as long as 10. But what we can also see is that if I make 6 and 4, that makes 10. I get one intersection point, but that doesn't make a triangle. So I also want to look at the fact that 4, 6, 10 does not make a triangle. So these two add up to 10. These two are under 10. These two are under 10. But here, these two, 6 plus 8 is 14. 4 plus 9 is 13. So those go above it. So what we actually want to see is that it's not that I just want to get there, but I actually want to get more than that to get my triangle. So I want my two sides to be larger than the third. The sum of the two sides to be larger than the third. But it's every side that we have to look at, because 10 may not be the fixed one. And so the general idea is that the two sides must add to be larger than the third side. And we'll go down here and we can make a little triangle. And so if we make our fancy triangle, and I label this A, B, C. I don't know any side lengths here, but I know that if I call this side length little c, if I call this side length little a, if I call this side length little b, I know that a plus b has to be larger than c. Not equal, can't equal it, has to be larger than that. I know that b plus c has to be larger than a, and I know that c plus a have to be larger than b. All three of these have to be true. Now, up here, when we know all three, we're just looking at the smallest two, because of course, if 10 is larger than 5 already, 10 plus 4 is larger than 5. So if 10 is larger than 9 already, 10 plus 4 is going to be larger. But sometimes we won't have that. And that's what this next example is. And this is the example that you guys will be looking at and doing. But if I have two sides of a triangle, if I have a side of 14 and a side of 9, so I'm just going to draw an arbitrary triangle in here and say that this is 9, this is 14, and let's just say that this is side length S. What has to be true? Well, I don't know exactly which one it is. It can be larger, it can be smaller. But I know three inequalities. One, I know that S plus 9 has to be greater than 14. Two sides of my triangle have to be greater than 14. Well, then I also know that 9 plus 14 has to be greater than S. So S can't be so large that it's not there. But then I also look at that last one and say 14 plus 9 has to be greater than, I'm sorry, I already did that one. The last one that we look at is 14 plus S has to be greater than 9. So those come from this down here. I just simply take two sides, say it has to be greater than a third. So I create all of those. But then when we look, there's one that that is already true. If I look down here, if I look at this one, no matter what S is going to be a positive number. S is going to be a positive value, or it won't be a side of a triangle. And so S, if I add it to 14, 14 is already bigger than 9. So no matter what S is, it doesn't matter what S is, this is going to be true. So I don't have to worry about that one. But these two I have to look at. So let's go ahead and solve these here. So if I have S, if I have 9, I subtract 9. So I know that S itself has to be greater than 5. But over here, if I add these two together to simplify it, I get 23. And I know that s has to be smaller than 23. So we can actually write an inequality here. I can say that s has to be greater than 5, but less than 23. Notice it's not equal then. It's not anything that it has to be 5. So can s be 5? No, because not 5 plus 9 is 14, and it has to be more. So could it be 5.1? Yes. 5.3? Yes. 6? Yes. Anything above 5. And I can't go to 23. I can be 22.9, but I can't be 23. And so notice how this is inequalities written. This is how we represent it. Those are the possible sides. So using this example and this idea down here that two sides must be larger than the third, and then this idea that the smallest angle is opposite from the small side, I want you to go ahead and complete the homework below on the Go formative. I hope you guys are all doing well. Tomorrow I will have a review posted and hopefully a video just describing the simple things that you need to have.